class, this video is going to help with 11.6 optimization, and I'm going to go over one example, and then I'll make a recording for the other examples to see if it'll turn out, because my sound is not been so well. All right, so optimization, what is this? This is actually the same thing as our last section, but in a word problem. Where is the highest or lowest point in a formula or in a function? Okay, so problem one. Okay, find two numbers whose sum is 10 and their product is the max. So we're going to take this information and we're going to find the max that fits this group here. So how do we write out that we have two numbers whose sum is 10? Well, I'm going to use x for one number, y for the other. So x plus y equals 10. Okay, and the product would be x times y is going to equal my max. So I want to use the max, but I can only have one variable in it. So basically, I'm going to use the first equation, rewrite it, and use it in that second equation. So rewrite this one to be y equals 10 minus x. Now put that here, and I have x times 10 minus x is going to equal my function that I want to maximize. Okay, so I'm going to times that through because derivative is how I find my critical values to see where it could possibly have the max. So I don't want to use product rule. I'd rather just go 10 times x minus x squared equals the function so that I can use the shortcut for the derivative. So to do the derivative, we'd get 10 minus 2x. Okay, now where does that equal 0 to get our possible spots that could be our maximum? So I'll minus the 10. I don't think I need to show that. I think y'all got that. Minus 10x equals negative 10. Divide by negative 2 and I get positive 5. So we have one value at 5 that could possibly be our max or min. How can we double check that this is concave the right way and that that's the max or absolute max or min? We can do that second derivative. So the second derivative would give us 10 minus x. Oops, minus 2x. Oops, no, I messed it all up. I was doing the derivative of the first one. I was like, that's what we just had. The 10 goes away and we're left with negative 2. I was like, it's got to be easier than that. So here's the derivative. Second derivative is just negative 2. I was thinking it was easier than that. What does that tell me? It tells me the whole thing is concave down. So that 5 is my absolute max. Perfect. Easy second derivative. I don't have to get out my graphing calculator and graph it. I just know that's my absolute max. Also a local max, but it's our absolute. So what do we do from here? We have to find y by plugging x into the original that we were given. So we put 5 in here and we'd see that y has to be 5 also. So the max is where x equals 5 and y equals 5. Okay? And then 5 times 5 is 25 if you needed to know that for anything for the profit. Or it might ask you something about the 5 times 5 for the product. All right, that's one example. Stopping this recording and I'll do another example on a different recording.